Hello everyone, welcome to this session. Chapter is map work, and we're still discussing about the scale. So far in our previous video, we discussed the various types of the scales. We said that there can be three types of scales: the small scales, large scales, and the medium scales. So today, let's see how you can express the various scales. Now, the following are just some of them. The first one is the statement scale. Now, this statement scale just refers to the scale which is expressed in terms of the words or explanations. So this is the first way on how you can express the scale on your maps. So simply by using the terms of words or explanation. Take an example, maybe 1 centimeter on the map is equivalent to 10 centimeters on the ground. So that's the statement scale. Moving on, we have the other one, that is the linear scale. This is also called the plane or the graphic scale. This is the kind of scale that uses some kind of a line just to express the given scales. This is the line which is divided into two main parts. There's the primary division and the secondary division. The secondary division are the ones that are expressed in meters and placed on the left side from the zero, and primaries are the ones that are expressed in kilometers and are placed on the right side of from the zero. So these two we just show the equivalence of the actual ground distances to the given map distances. The third one is the representative fraction scale. This is written as the fraction or ratios. Take an example, one ratio of 50,000. Now the distance on the map is the one that is expressed as the fraction of the actual distance on the ground. Therefore, the representative fraction scale is just equals to the map distance upon the ground distance. The top number here, talking about the numerator, is just representing the map distance on the ground, and it is usually more than the other one. Now let's see the scale conversions. Here I'll see how you can convert maybe statement scale into a representative fraction or representative fraction into a statement. So starting with the first example, we're given here a representative fractional scale. We have to convert it into a statement scale, 1 ratio of 50,000. Now uh, solution, we know that 1 kilometer is equal to 100,000 centimeter. Now take the denominator, that is the 50,000 divided by the 1,000. I mean 100,000 actual number in kilometer. So if you take 50,000 you divide by 100,000, you get 0.5 kilometer. That's so 1 centimeter to half kilometer, that is 1 centimeter to 0.5 kilometer. So we've changed this representative fraction scale into the statement that this representative fraction scale just says that 1 centimeter to half kilometer in statement scale. Moving on. Now, let's see the other scale convention. Here, we're going to change the statement into a representative fractional scale. We're given 1 centimeter represents 60 kilometer. Now, solution, we know that 1 kilometer is equal to 100,000 centimeter. Now, 60 kilometer will go to how many kilometers? I mean, how many centimeters? So, if you cross multiplication, it just be equal to 1 ratio 6 million. So, therefore, representative fraction of this is just 1 ratio 6 million. So, we've changed the 1 centimeter representing 60 kilometer. This statement scale into representative fraction scale as this one ratio 6 million. Now let's see the various importances of the scale on the map. The following are just some of them. Scale just helps to calculate the area of the map. You can calculate the area of the given map simply by using the scale. So without the scale, you can get a clear definition of the area of the map. The scale on that, it enables us to calculate the distance on the map. So scale has just been there just to help us to calculate our distances that can be found or that are shown on the map. So without it, you can't calculate the actual distances which you are shown on the map. The other than that, the scale shows the relationship between map distance and the ground distance. So the scale is there just to show how the map distance and the actual ground distances are related together. So in this way, you can simply understand it clear how the map it illustrates all these two kinds of distances. The other one that scale helps to enlarge and reduce the area on the map or the whole map. So the scale is there just to help you to enlarge or reduce the various areas on your given map with the very actual dimensions. So without scale, you can do that. The scale can also be used to calculate the vertical exaggeration on the map. So scale helps that also. And last but not least, the scale is used to calculate the gradient on the map. We are talking about the slope. So the scale can be used to calculate the gradient or the slope that can be found on your map. So that's all I have for this session. That's all clear. I've discussed the various ways of expressing the scales. We've seen that there are three of them: the representative fractional scale, the linear scale, and the statement scale. And we've seen some of the conversions of these kinds of scales from one to another one. I hope that's clear, and thank you.